Okay. So, what do you have done last time? Math, right? On math. Okay. Huh? What you have done last time? Math.
Yes, sir. We did practice on.
Okay. Um, I have uploaded one. Let me switch on my other. I have uploaded one class note. Did you see that in the Google Classroom?
Yes, sir.
That is actually the class notes of yesterday in the lab class. We have done one math. Let me see. I can find it again. Second screen. Windows key plus K. Connecting. Okay. Fine. Right. All right. So all right. How about the group? Did you submit your group?
Sir, we couldn't fill up the form
Or not?
because when we want to fill up the form, it shows that we need some kind of permission, sir.
Did you check again that I have said that I fixed the problem? You didn't check it again. Please check again and please submit and make sure that we have only maximum 3 members. Maximum 3, minimum 2. It is clearly written. I don't know why you're still asking me. Maximum 3, minimum 2. Right, so please submit your form as early as possible. And that is the lab we have. Not that is the class we have. Oh, and let me share the screen. Okay, so that is the this is the task we have done yesterday, which is you can see this. Okay, this was the circuit. This was the circuit. The circuit was similar, like we have an register here. So the main task was to find out the current go through these registers. That was the main task. So we have done everything. You can see we have done a lot of things to find out the ultimate result, which is this one. Yeah, which is this one. So if you follow step by step, here, I think it will be helpful for you to understand how to solve similar type of problems. Okay, let me explain, then you are going to do it by yourself. So, okay, the main circuit was this one. And This was the main circuit. Oh no, not this one. Which one? This one.
Yes, sir, this one.
This one was the main circuit. Look at the circuit carefully. And the question was that what is the current go through this 100 ohm resistance? That was the question, because 100 ohm, this one, this is actually the RL, and we have terminal here X and Y, you can see that. Right, so that is our ultimate question, that what is the current go through 100 ohm resistance? So you can solve this one, or if you can solve this circuit in many different ways, by using Norton's theorem, Thevenin's theorem, current divider rule, Ohm's law, or combination of them. So yesterday we have tried Thevenin's theorem, of course, to solve this one. So after having this, okay, our first target or our initial target was to find out the equivalent circuit. This is the equivalent circuit of the previous one.
Yes, sir.
This is the original circuit, and then this is the equivalent circuit of this. So to have the equivalent circuit of that, we have done everything. You can see that this is for E naught, that is for R naught. So we have done this one. After doing this one, because our ultimate question was, what is the current go through this 100 ohm resistance? So after having this equivalent circuit, it is very easy to find out what is the current go through the 100 ohm resistance, because it is using the simple Ohm's law, which is I equal V by R. In this case, V equal to E naught, and R equal to R naught plus RL. You can see that because it is a series circuit, and in the series circuit, all the currents through all the components are same. That's why. So if we do the calculation correctly, that is the answer. Fine. So that we have done yesterday. So any question?
Sir, is after I2, is it I1 or I3, sir?
Which one?
Sir, on the second junction, on the
Second junction,
Yes, sir.
I1.
Yes. Okay, sir.
This is I, this is I1, that is I2. Or it is your choice, whatever you name it. But here I have used I1. So total current is I. Total current is I. The branch current go through the 500 ohm resistance is I1. And the other branch is I2. And why we need to, can you tell me why we need to find out I1 here?
Because here is a branch exist.
Mm-hmm. No, but fine.
And
Why? Whenever we try to find the E naught, why we need to find out the I1?
so here we আমরা মনে করি যে মানে with
the
current flow through the 500 ohm and the RL are same, we think.
Not current flow. You're close, but not correct. Anyone else?
Voltage, sir. Another voltage.
Voltage, yes. The voltage across the 500 ohm resistance and the voltage across this terminal, which is E naught, they are assumed to be same. That's why we need to find out the voltage here, V500. So to find out the V500, of course, we need the current go through this resistance. That is I1. That's why we need I1. Fine.
Yes, sir.
Any question? Think about it, please think about it. Otherwise, we are going to, because we are going to solve similar kind of another problem. So please try to understand that how we have done it. And if you think any issues or any problem, you can tell me.
Why did we consider 60 ohm when we measured the RT?
RT, why
Yes.
RT? Oh, RT, why we
Why didn't we consider 60 ohm?
60 ohm? Because the same reason, whenever it is finding out the E naught and we are finding out the I, did you see that it is actually not going through this current? I mean,
Oh, okay.
current is going through the 60 ohm resistance. No, right?
Yes, sir.
So there is no effect on the total current of this resistance. That's why.
Got it.
But we have considered the 60 during the R naught, because during the R naught there is no current flow, and we consider all of them. Look here.
Yes, sir.
Any other question? Think about it, let me know. And this is a very popular type of question in the exams. So it's better that you know it very well. Anyway, the book, let me check. Whatever we have discussed yesterday, or tried to discuss yesterday, because not yesterday, day before yesterday, last class, there was so many interruption, but still, I hope you still can remember the explanation of this, right? This one and that one is same. This one and that circuit is same.
Yes, sir.
So I hope you understand how we have solved this one, although they have not written any explanation, but we have discussed the explanation that why we have, how we have find 2.5. So if you can understand this one, you should understand this and all other similar type of problem. But
Yes.
still, I know some of you still have some confusion. That is absolutely normal. So that's why I'm asking again and again that please try to find out the issues, or try to understand, or try to, remove your confusion regarding this type of math. Because as I said, it is a very, very common math, a very popular math for the exams, all the exams. And if you can solve this kind of problem or this kind of circuit, I hope you should not have any problem of any other circuits. And that is the two circuit we have, E naught and R naught. And this is a similar way we have found the current go through this 100 ohm resistance. Look, they also have done in a similar fashion. That means they have found the equivalent circuit first, and then after that, they have found what is the current. So current, voltage divided by resistance, voltage divided by 2 resistance. That is the ultimate answer. How about the rest of you who actually never speak? Do you understand, or do you have any problem? If you have any problem, then we will discuss, or we'll just revise it again. Otherwise, we are going to practice. Some, I mean, yeah, some of you actually already says like no problem, but I'm asking about the others. No problem.
Sir, it would be good if you revise it again.
This one,
Yes, sir.
okay. As I said that we are going to find out, you can see the question here. The current go through the 100 ohm resistance. So that is our ultimate goal. So to do that, we need to simplify this circuit. To simplify the circuit, they have asked it using the Thevenin's theorem to simplify this. So we are going to simplify this circuit. So to simplify it, first of all, we need to find out R naught. So let's find out the R naught. And I hope you know that to find the R naught, we need to do two things: remove the RL and make it open, and remove the voltage source and make it short. Fine. And then we need to find out, or we need to consider the R naught from the terminal. Here is the terminal. So we know that wherever we consider, we should start the calculation from the other side. Right, so the other side is this on the left side. So if you want to find out the R naught, the equation will be 10 parallel 20. Then whenever you combine these two, it will be series with 12. Whenever you combine three of them, then it will be parallel with 8. That's why the equation can be written as R naught equal 10 parallel 20 plus 12, and everything was parallel with 8.
Yes, sir.
That is the R naught. And if you do the calculation properly, that will be the answer. Now, the second one, which is E naught. E naught. So again, to find the E naught, we need to do one thing, that we need to remove the RL and
Sir,
make, yeah,
sir, here 8 ohm, it will be parallel or series.
it. Okay, whenever you combine these, okay, let me draw it. 1 minute. So our circuit was like 1 minute. 1, 2, 3, 4. Right. Let me draw. Can you see my whole scheme?
No, sir,
Yes, sir.
only the,
Only the whiteboard.
yes, sir.
Right. Okay. So what we have done here, our circuit is like this. That is the 100. By the way, I'm writing in my pad, so much better than the mouse. So this is our circuit. So whenever we are trying to find out the R naught, what we need to do, we need to remove this one. So whenever you remove this one, it should be open like this. And also we need to do one thing, we need to remove, we need to remove, we need to remove this one as well and make it short, right? So now we need to find out our R naught from this side. Okay, so if it is R naught from this side, it is 8. Okay, if we want to find out the R naught from this side, what is the rule? We should start the calculation from the other side, right? Okay,
Yes, sir.
so if we want to start the other side, let's say 10 and 20, they are series or parallel, right?
Parallel, sir.
Okay, so if you combine them, the circuit should be look like this. Let's say you combine them. This is the combination. So this is the combination of these two. And this one is as before. Fine. So the next step is this one and this one, they are series or parallel?
Series.
Series. So if you combine them, it can be look like this. After combination of these two. So this is the combination of these two. Now what do you think? This one, this combination, and this 8, series or parallel?
Parallel, sir.
Parallel, sir.
Okay, now you have the answer. Who actually asked me about the series or parallel?
Yes, sir.
Fine. Okay, that's why the combination of this one and the last one, 8, is parallel. Right. Okay.
So, but I think that after 8 there is no current divided there. So I think there's this series.
Now whenever you find the R node, you don't need to think about any current. All right, because you just need to think about all the registers. That's why all the registers. You don't, because why you need to think about the current? Look, we don't have any voltage source here, right? So no voltage source, you don't need to think about the current. You only think about the resistance, nothing else. Right?
Yes, sir.
Any other confusion regarding R naught? No? Okay.
No, sir.
Okay, then, fine. So that's how we can find out the R naught. But the main problem was, I think, the finding the E naught, because you need to find a lot of things. You need to find I1, you need to find I, you need to find RT, a lot of things. Actually, you should have problem here. So think about it. Where is the, if you have any problem? Look what we have done here. We have find out the RT first, right? We need to find out the RT first, then we find the I, total current I. After the finding the I, we put the value into this equation of the branch current, then we find the I1. And then the value of I1 is putting into this ultimate equation, V equal to IR. Then we got the E naught. So there are 4 steps to find only the E naught. Need to find RT, need to find I, you need to find I1, and then ultimately you can find the V or E naught. And that will be your E naught.
Sir, can you please repeat the process of RT?
This is the process of
RT, Thevenin's resistance.
okay. So whenever we find the whenever we find the E naught, that means we have voltage. And that is our terminal. Fine. So the current is actually flowing from here, right? That is our total current I. That is 100 volt. Okay. Now we need to find out. We need to find out what is the current I, total current I. So which way the current starts flowing? From the left side, right?
Yes,
so if you want to find out the current, if you want to find out the total resistance, the rule is you should start the calculation from the other side.
Yes, sir.
12, it is 12, right? 12, yeah. 12 and 20. How about this one? 30.
15.
30. It's 30 or 10?
Sir, 10, sir.
10, sir. 10.
Oh, sorry, 10, 10, 10. 10. So whenever we write the equation of RT, the total resistance, we should start from the other side. So if it is from the other side, it should be 12 plus 8, right? Because they are in series.
Yes, sir.
So they are in series. So if they are in series, after making them 1 into 1, so the combination of these two will be parallel to 20, right?
Yes, sir.
So parallel. So parallel to 20. So parallel to 20. So the combination of all these three,
Will
will
be series with 10.
yes, with series with 10. So that is our equation of RT
Yes, sir.
of this circuit, remember,
Yes, sir.
of this. Of this circuit. We are discussing about this circuit.
Yes, sir.
All right, so whenever we find the E naught, so you remove it and then try to find the I from a total I. So that's why the total resistance, we start from the opposite side. That's why we start the calculation from the rightmost side. That's how we find I, total R and I. Any other issue? Thanks for asking questions, by the way. That means still, I know, still you have problem.
Sir, can you please go to the previous artbook?
Previous?
Previous artbook?
Oh. This one.
No, sir. Yeah.
This one.
Sir, from the last class. Artbook of the last class.
From the last?
The artbook from the last class.
Oh, the last class.
Yes, sir.
Oh. Let me see. This one.
So nothing is visible here.
Oh. This one.
Yes, sir. So here RT is that total resistance?
RT is total resistance, yes. 40 plus 500 parallel 200 plus 30. 40 plus 500.
Yes, sir.
With parallel with 200 and then series with 30.
So what about 60 ohm? The
60.
rightmost, yes.
60 will not consider because whenever we find the I, there is no current go through the 60.
Sir, I'm confused here. Sorry.
When we find the current total I, is there any current go
Oh,
through?
yes, sir. No, sir. Because the circuit is not closed. Yes, sir.
Yeah, that's why.
Oh, okay. Thank you, sir. That was my actual question.
Okay. Any other problem? I know there were so many issues because it's a lengthy process. So it's quite normal that you have so many confusion. So it is better that you try to avoid or try to remove all your confusion so that you can solve it a similar kind of circuit. Any other problem or issue before we have another circuit to practice? Let me find. Can you see the circuit?
Yes, sir.
Yes, sir.
Have you done this one before?
Yes, sir. I guess we have done this for Arnold.
Have you found the current go to the 300 ohm resistance?
No, sir.
Okay, let us try then this one. Almost similar, but easier. So your target is to find out the current go through this 300 ohm resistance by simplifying this circuit. Let us find the simplified circuit first, E0 and R0, and then you can easily find the current go through this 300 ohm resistance. Let us do it, everyone. Please do not send me this kind of message that you have this problem, that problem, to give you the attendance. To all of you, that is a request that please do not send me or do not request this kind of, illegal request to give you the attendance. During the class or during the taking the attendance, if you're there, you'll get attendance, otherwise no attendance. So you have to arrange your, whatever it is, mobile phone, tablet, or any other device to prepare yourself for the class. No excuses will be listened or will be entertained. Your area doesn't have electricity, your area doesn't have current, network, your problem. Why you go to your village? Same thing every time. As you know me well, that I actually don't like excuses. And there is no extra consideration to get anything from me. You know the answer, you have the skill, you write the correct answer, you will get marks. Finish. No other consideration. I think that's why there's a very good number of fail in my section. Because I try to follow the rules. And the problem is nobody liked the rules. And it is the problem whenever I also drive the car. When I drive the car, I follow the rules. Follow the rules means the traffic rules. You should have a distance, you should maintain the lane. You should overtake by, if you want to overtake some car, you should do the overtake on the proper lane, you do the proper indication and everything. And I follow all the traffic rules, which is our traffic rules in our country. Don't think that it's traffic rules from other countries. Our country's traffic rules. But the problem is other drivers doesn't care. Other drivers do not care about the rules. So they do, or they drive wherever, whatever they want. And then there is the problem. Because not following the instructions or not following the rules is our habit. And we think that it is normal. We think that it is normal on the road. We think that it is normal not to follow the rules in every part of our life. That's what I don't like. Whatever problem, I might go slow, maybe, on the road. So many cars actually can pass through me only to follow because I follow the rules, that's why. So what? No problem. Same to you as well. Doesn't matter you like it or don't like it. Doesn't matter other faculties do it or not do it. Doesn't matter that you have some other problem with that. I will consider if there is any emergency, which is unavoidable problem, let's say your sickness, your other family issues, that's fine. I'll consider, no problem with that. But the problems you can solve, or you create the problem and then asking the solution to me for consideration, those kind of problems I will not consider. For example, in your area, or you have network issue.
Please, can you hear, sir?
Anyway, we are disconnected. Wait 1 minute. Where is the this one? Can you see now?
Yes, sir.
All right, fine. So please continue.
Sir, is it 0.0457 ampere?
I don't know. I don't have the answer. You will tell me the answer. Maybe, maybe not. So you have used all on the Thevenin's theorem or anything else?
No, sir. I just found the total resistance. Then I applied, sir, current divider rule 2 times.
Current divided rules 2 times. Okay, fine, no problem. So wait for the others. Let's see what others can do. But it is Mr. Sobol, it is better that you use the Thevenin's theorem because we are practicing Thevenin's theorem. You can solve it in the but it is better that we are trying to learn the Thevenin's theorem. So it is better to use the Thevenin's theorem. All right.
Okay, sir.
So let's do it in the Thevenin's theorem. And then let's see it is the same answer.
All right, sir.
Sir,
Yeah.
I got sir 0.03505, 0.035.
Is it this? Okay, one by one. What is the total current?
অনেক বুদ্ধিমান একটা ছেলে একটা টিচার মানুষ ভাই
Uh,
Sir, total current I got 0.0912.
total current I is equal
0.0912.
So is it the same to others?
Sir, I got 0.1678 total current.
Oh, why?
Sir, I got RT and R naught and then divided it by
No. You need to find the RT first only to find the I. What is the RT?
Sir, RT is 595.7446 ohm.
Is it the same to others?
No, sir.
Sir, 1095.
Yes, sir. 195.
Yes, sir. 1095.7446.
So I think that is the correct one, sir. 1095 point.
7426.
Okay. So if it is the RT, then it is very easy to find the total current because RT is equal, our total current is equal 100 divided by 1095.7146.
7426. Yes, sir.
So the total current should be 0912.
Yes, sir.
Is it the same to others? Total current?
Yes, sir. Very close to.
Total current, okay, let me write it down. So your total current I equal to 0.0912. Is it the same to your answer?
Yes, sir.
Rest of you?
Yes, sir.
Or you're still doing, because if you think about the RT is equal 1095.7146, right?
7447, sir.
7447.
Oh, 7447. That is your RT. So to find out the I, obviously, it should be 100 divided by 100 divided by these values. Oh shit. Copy paste, and that is your answer I. So if it is the same, so do step by step. You check your RT, check your I. So after finding the I, you need to find out your branch current, right? So what is the name of your branch current? Let's say I1. So what is the value of I1?
Sir, 0.07767.
0.076.
6. Is this the I1? I mean, or the branch current to all of you?
Yes, sir.
If not, please also tell me, the rest of you. I don't know the answer, that's why I'm asking. I think all the rest of you have not done it. That's why.
Actually, I got, sir, RT is 0.6257.
Huh? RT?
Yes, sir.
What?
0.625. I converted it kilo ohm
Why you convert the kilo ohm?
because it's mentioned one is the 4 kilo ohm.
Yeah, so it is not really necessary. It is not really necessary to. So one is the 4 kilos. So 4 kilo means 4,000.
Yes,
Simple. So no need to do the kilo because whenever you do all the calculation, we have not convert anything to any other. So it is better you use the
In this case,
basic.
don't we need to convert it into ohm since the rest are ohm?
Yes, the rest of them are ohm, so there is no need to convert it into kilo ohm.
First, we have to make it ohm, then we have to calculate.
Yes, yes. You need to convert this 4 kilo ohm into ohm, which is 4,000, and then do the calculation.
Yes, sir.
Yes, sir.
And the answer is 625.7446.
Which one?
So RT.
No, RT is 1095.7146. By the way, the equation of the RT is 500 plus 200, right? 500
Yes, sir.
plus
Yes, sir.
200.
520
4,000.
parallel 4 kilo ohm.
Parallel 4,000 and then plus with 500,
And
right?
series with 500.
Oh, sir.
So
Sorry,
it's,
sir. I got, I mistakenly entered wrong value.
yeah, that's why. So please make sure that you write the correct equation before you do the
Equation is right, sir. Put the wrong value.
whatever. How about the rest of you? It is the same. Is it the same answer to all of you? Until the I1. That is our I1.
Yes, sir. Same.
Okay.
Same, sir.
All right. If it is same, then what is the next value we need to find out?
E naught, sir.
E naught, or let's say the V, right? V300, right?
Oh, yeah. Yes.
V300 or E
Now
naught.
is correct.
Huh? Or E naught equal to
I1 or 200.
this one multiply I1 multiplied by 200, right?
Yes, sir.
Oh, it is 200. Okay. So what is the value?
Sir, 15.5339.
Yes, sir.
10776 multiplied by 200. What is it again?
Sir, 15.5339.
15.9.
5339.
339. Okay, so that is the answer. That is the E naught.
Yes, sir.
Is it the same to all of you or similar?
Similar.
Yes, sir.
Okay.
Yes, sir. It's
Very close to this one.
Close to this one. It's fine.
Yes.
Okay. And how about the R naught?
Sir, R naught is 143.1793.
I got 165.0485.
Sir, R naught is 165.0485.
165, sir.
Sir,
165.
Okay. Whenever you try to find the R naught,
165.
okay, listen. Whenever you find the R naught, the equation of the finding the R naught is 500 parallel 4,000, right?
Yes, sir. Yes, sir. Some my equation was right, sir, but I consider 4, not 4,000. That's why I did mistake, sir.
Then how come you do the RT? RT is during the RT you got 4,000.
No,
right?
sir. RT I use 4,000, but at the time of R naught I use 4 only.
Okay then. So what is the correct answer?
165 point
0485.
165.0485. 165
165
.0485.
0485. Okay, is it the same answer to all of you or close?
Yes, sir.
Yes, sir.
Fine. Then what is the current go through the 300 ohm resistance?
0.03.
0.0333.
33.
Ampere. How about this answer? Is it the same to you as well?
Yes, sir.
Yes, sir.
0.033 ampere. So if it is the same, then it's good. Let me give you that. Okay, so please respond in the Shuman Rana.
Yes, sir.
Ajmus Sakib, Binoy Krishna, Ashfaq Hussain, Ishrafil Hussain,
Present, sir.
Sonia Akhtar,
Yes, sir.
Kondakar Tanvir,
Yes, sir.
Majia Rahman,
Present, sir.
Mahfouza Akhtar,
Yes, sir.
Sadiqul Islam,
Yes, sir.
Rifatul Rahman,
Present, sir.
MD Ali Onim, Sultan Rajia,
Present, sir.
Rubel Babu, MD Sajid,
Present, sir.
Didar Al Mahmud, Rawab Khan,
Yes, sir.
Abdul Sabur,
Present, sir.
Nur Anjuman,
Present, sir.
Sharafur Rahman, Mehdi Hassan,
Yes, sir.
Mehdi Hassan Midul, Ashraf Mahmud,
Yes, sir.
Naushid Nafifa,
Present, sir.
Mahbub Alam,
Yes, sir.
Imrul Hassan,
Yes, sir.
Ashikul Jaman,
Yes, sir.
Sadia Sal Sabin, Torum Bishash,
Present, sir.
Najmus Sakib,
Yes, sir.
Mahir Morshed,
Yes, sir.
Abdul Razak, Tawhid Ahmed,
Yes, sir.
Kondakar Asfim, Hassan Arafat, Shamin Akhtar,
Present, sir.
Shaukat Hussain,
Present, sir.
Mona Hussain, Samantha Jaman,
Yes, sir.
and MD Shahriar Hussain.
Yes, sir.
Okay. Anyone else? No, it's fine. Thank you very much, all of you. Tomorrow we have another class, right?
No, sir.
No, sir.
No, sir.
We have class on Sunday, sir.
Oh, tomorrow is Thursday. Today is Wednesday. Oh, okay. Next Sunday, right? Okay. Okay, then thank you very much. See you on
Sir,
next.